Good. As usual, tradition, we're going to start off with a little video. All right. Just a quick show of hands. How many folks have seen a version of this talk before? Yeah, a few of you? Well, that's good. Well, there's a couple of interesting things that we're going to show today. We're going to show a couple of things that nobody has seen before outside of Microsoft. In fact, there's many people at Microsoft that haven't seen the things that we're about to show you. Second, we have a very special guest with us, Perry. So the combination of that should not just be exciting for the folks that haven't seen the talk before, but also for the few of you that have seen it before. My name is Vivek Sharma. I spent a lot of time working on the service, and today what I want to do is go from what marketing likes to show you, nice, well-kept data centers, beautiful, I would say, data centers. I think they would even say that Cortana lives there in those data centers, to what really happens in engineering. It's a lot of hard work. There's a lot of forklifting going on, and more than a few mess-ups. That's an actual shot. Both are actual shots of our data center, one of our data centers, one of our many data centers at Microsoft. So you shouldn't expect this to be like a sales pitch. This is not about that. This is really about us being super transparent about how we run the service, specifically Exchange Online. And we like to do that. So you should feel free, if we have time afterwards, to really quiz Perry on how far we've gone with running the service. The other thing I want to be able to say is there will be some numbers that you see here, and there's a couple of numbers that you saw in the video. The great thing about running a globally massive service is that by the time I have the chance to disappoint marketing by showing numbers here, they're already stale. For example, Satya said that we were 50 million active users in our earnings call about a week and a half ago or 2 weeks ago. Well, the video showed 44 million, so I don't feel bad about sharing that number. There are going to be some numbers, however, that you're going to get a sneak peek into, and I just ask you to close your eyes. And it's also, I think, a little bit of a marketing mistake to have two individuals co-presenting this talk whose motto in life has been, ask for forgiveness, not permission. So you're probably going to see a lot of things today that you've never seen before. So with that, I do want to introduce Perry Clark, if everybody knows. Come on up, Perry. Perry's going to walk through our Exchange Online scale. And we'll take questions afterwards.
Thank you, Vivek. So Vivek spent a lot of time getting this talk together. And when we were going through it this weekend, sort of an email conversation was suggested that since Vivek's had a lot of success with this talk, maybe my presence might be a bit superfluous. And she replied back, well, you know, when we advertised Ignite, we put you down as a speaker, so to be clear, you need to show up on stage for 2 minutes. Otherwise, we're contractually at risk of getting sued for false advertising. All right. So first I'm going to show a few slides about the scale of the service and try and get a little bit of credibility about the rest of the talk based on where we're at today. And one of the grounding points of this talk is the scale of the footprint across the globe of the data centers that the Office 365 is present in. And one aspect of this is just a big number, and the pipeline is full of new geographies. But another reason I like this slide so much is because something I feel deeply about is that Microsoft's got a deep commitment to recognizing the need to respect the regulations, the compliance needs of companies around the planet. Human beings live in countries. Most of these countries are democracies. They get to vote for their own governments, and those governments get to set the rules. And we're going to respect those rules because that's about the rights of people to live in democracies. And if all the content is in one country, then you've got some deep conflicts between those rules that can't just be resolved. Nobody's going to accept a world in which the United States makes all the rules. Nobody would want to do that. Similarly, nobody in the United States is going to accept that, you know, Switzerland is going to make the rules for who gets to look at the data of American citizens. So this embodies a deep commitment to the planet that we want to put and grow with the planet and recognize the need for respecting those wishes. All right. So we're pretty proud of this slide. This is about data that's about a year stale, as Vivek said. You know, we're a little careful about showing where we're actually at any given point. It's basically a count of servers in the Exchange part of the Office 365 service. It's pretty rapid growth. 600% over that time frame is nice exponential growth. And that looks pretty impressive. And the rate at which we are deploying servers is really rapid. And every time you see one of those sort of slightly flat lines followed by a little jump at the end, that usually involved that period just before the jump usually involved a bit of a panic and often a meeting in my office involving Vivek and Rajiv and deciding who wasn't going to go on Christmas holidays to make sure that we caught up to the growth in demand with the servers that we needed. Okay, so that's what we did in the past year. One way to think about that is we've deployed as much hardware as we did over the previous half decade in the past year. Another way to think about it is right now we're deploying in a day as much hardware as we deployed in the first year or two of the existence of the service. The scale and the rate of change is insane. And this curve is going to continue. Our projections show next year when we show the slide, it'll look exactly the same. The part will just shift over, it'll just squish it down, it'll just look like the blue part, and the new part will look the same because we're on the same exponential growth curve. Keeping up with that is the challenge, or one of the challenges. Okay, so scale is a key part of what the cloud's all about. And when people think about moving to the cloud, what usually jumps to mind is, hey, there's all these fantastic economics of the scale of the cloud. You guys get to buy hardware really cheap. You get to optimize all the components. You get to build in data centers that are massive and locate them close to cheap power. So yeah, you're going to have a really low-cost story. And that's what the cloud is all about. It's going to the cloud so I can get a cheaper email service. But over the history of Exchange, every major release, marketing's always come up with three pillars. And there's always three pillars. And the pillars are always the same thing. There's a pillar that's about cost. How much it's going to cost to run Exchange on premises. There's going to be a pillar that's about the value proposition. How much the user experience, the productivity of users is going to improve with this release. And then there's going to be conversation about how we're improving the risk profile for the companies that deploy the new thing, either through better retention policies or data leakage prevention technology, or improved high availability story, or regulatory compliance features, right? The reality of right now is shifting to the cloud, and one of the reasons this is a big bet is, well, this appears like this might be a complex, tough choice. To get the cost, what am I going to trade off against that cost? Maybe I can get a better user experience because you get to deploy sooner and you get to use the latest features sooner. So you can see how you could, maybe another value proposition is that you also get a better user experience out of the deal. But surely I'm taking this at the expense of risk. The risk of my company, knowing where my data is, isn't that a problem? But I think that's the other side of this coin, which is at the scale that we get to operate at the cloud, while it's a challenge, it also enables us to invest in systems that tell us exactly what's going on faster so that we can respond to risks quicker. It allows us to invest in systems so that nobody has standing access to important data or destructive operations within the organization. That we can spot a red team Microsoft credentials. We can spot the red team my credentials, and they still can't do anything. And that kind of investment just can't be done for a 1,000-person company or a 10,000-person company, because they get to amortize that over, 0.01 petabytes, and we're amortizing it over 150 petabytes of use storage. So the reality of it is, at the point in time we're at, this is one of the few places in which all three aspects of the decision are just clearly better. And I think an awful lot of what Vivek's going to talk about in detail should help to reinforce why we think that's true. So over the last few years, I've been asked to give a few talks that are about what we learned from going to the cloud. And this is sort of boiling it down to one slide. And there's really two things that are really important. One is, as you scale exponentially, if you're being successful, that's what's happening, everything is going to break eventually. It's a question of when. And the other thing is, the thing that's really different about a cloud service is time. Your ability to respond to incidents and make changes is so dramatically different than pushing through the pipeline that allows people to deploy new bits and diagnose issues when you're on premises, that your whole thinking about how to build the system has to change. The focus on the rate of the number of defects, while important, isn't nearly as important as making sure you take advantage of the time to recover. And if you can drive down that time to recover, you can deploy a very reliable service and keep it up to date in the face of massive change. And it's enabled by the scale of the system, because the signals that we generate are huge and constant. And we can build and invest in machine learning and data analytics on top of just the information flow about the system that's running. So we're not only building the instrumentation into the service to tell it what it's doing, but we're also building very complex machinery that analyzes that stuff in real time and allows the service to automatically notify, automatically repair and recover. And then the direct access to the actual engineers who built this system, who get woken up in the middle of the night based on the alerts and the machine learning systems that they built, and get to respond to things that are unexpected. Also make sure that that loop is very tight. It's not very many times an engineer gets woken up in the middle of the night before they have very good ideas about how to address the issues. And then this also feeds in on the risk profile side and the security side. The system is also telling us about threats and to the system, and also enabling us to build systems that allow us to repair, change systems without giving access to the underlying data, without giving engineers the access to doing destructive operations, because we're doing something at a meta level. But ultimately, it's a process, and that's the key thing, is keeping this loop nice and tight so that engineers are constantly noticing where things are being defrayed at the edge and then addressing them in real time before we run out of capacity or scale and have an impact on the service. As an example of something that breaks as you scale up, on the left-hand side, you see our original network diagram. We've got L2 routing all the way down to individual machines. And these very expensive AG switches and host switches. And the complexity of the system and the expense of the system was amazing. The expense was a little secondary. It was more of an indicator of the complexity of the system. And the failure modes were dramatic and unpredictable, and the scope of those failures were huge. The shift onto the right-hand side dramatically reduced the bill for the hardware involved. Those border routers and top-of-rack switches are really much simpler systems, especially the top-of-rack routers. And because they're simpler, they're dramatically cheaper, but even more importantly, they turn out to be also more reliable. But the key here is we made the bet on the N-way redundancy we have at the data center level. That commitment to having lots of data centers around the world means that if we lose a server, or we lose a rack, or we lose a border router, or a DC router, or a whole data center has a power failure, the failure mode's the same to us. We switch out to another data center, and we have enough that has very little impact on our capacity. And the speed with which we can do that is very, very rapid. Again, coming back to the MTTR thing. All right. So a little bit more recent data. This graph you can't really see the curve on this graph, but this is just a 3-month time frame. And you've seen a 60% growth in the number of transactions over that time frame. Keeping up with stuff like that is tough, but we are doing it, and we're doing it at much higher availability than our on-premises products can do. Here's one last slide I just want to leave you with, just to give you, over the past year, the growth in one aspect of the system, which is our end-user auth requests. And this is a combination of the new users and companies coming into the service and the richer ways in which they're using our service and driving up the load incredibly dramatically. Okay, well, so that's sort of my introduction to what Vivek's going to be talking about for the rest of today. So thank you for your attention. And if we have some time, we might be able to take a few questions at the end.
How about another round of applause for superstar Perry Clark? I love this slide because, when it comes down to review time, I just kind of show this and say, we're still here. And, of course, it's well received because we are still here. Our stuff that we use to manage the data center is quite complicated. None of this is possible if we just think of Exchange Online or SharePoint Online or Lync Online as being monolithic services. It's not just that we have one giant farm. We have to break up and chunk up things in order to scale. Perry talked about this in terms of the 4-site design that he alluded to in part of the network diagram. Our service is quite complicated. When you start chunking up and breaking up things into little pieces, it makes the scale out incredibly easier, better for the engineering team, but it makes it incredibly harder in all those other dimensions that Perry talked about. Deployment is tougher. There's not just one thing you have to deploy to. There's thousands on thousands and thousands of things you have to deploy to. You have to monitor sometimes thousands to millions of entities and objects. So we invented this thing that I've colored in this pink color here, or purple-pink color. We call it our data center automation stack. It allows human beings, normal human beings, to somehow transact over all those hundreds and thousands of entities and manage to run a global service at scale. And that's the thing that I'm going to kind of show you. The video alluded to some of this as well. The real clever stuff that we've been able to do here is somehow take Exchange as you know it, transform it to the cloud without really disrupting all the things that people care about, people in this room care about, which is the user experience, and delivering that faster and faster and faster. And of course, a lot of this stuff, in fact, all of it, is built expressly for the purpose of managing our partitions, our scaled-out machines, our user base. And a few slices of this is what I'm going to show you today. But the point of this slide is we had to invent almost an entire group of technologies just to be able to go scale and manage Exchange online in the service, way beyond all the things that you are familiar with. And to be honest, you're not going to see any of that stuff on premises. One, because of the scales that we're talking about, on premises versus the global scale, they're just not relevant. And second, some of these systems are so highly purposed that they would be utterly useless on premises. And I'll show you a couple of examples of that. First thing I want to show you is, I usually like to take a little pause and show some things, again, like I said, beg for forgiveness after the fact. Let's show some things that I think folks have not seen ever before. So this is Microsoft's global network map. And it's kind of interesting. A couple things interesting. One is, holy crap, it takes a long time to scroll through all of it. And second, boy, there seems to be a red link. I'm just going to ignore that part. I'm sure our top engineers are on it right now. Probably some of them are getting on calls right this instant. But the magnitude of the world that we manage is quite massive. Now, this is way more than the locations that Perry showed you. One, because we don't tell you all the locations where we are in the world. And second, these locations, some of them are simply network connection points between data centers. So we invest not just heavily inside the physical footprint where servers serving your data live and reside, but more importantly, we hook up all kinds of peering relationships all around the world so that it's possible for us to transact user traffic efficiently with reasonable latency, quickly and easily around the world. The clever thing that I've found out of this map, and one, it was very liberating for a lot of us who are running the application. We built Exchange Online or Exchange for many years from the IT perspective, but when we had to run it ourselves, we were kind of confronted. This is me being openly transparent and a little bit too candid. We were confronted by that fact that we really didn't know how to run our own product. It's okay to laugh. We literally did not know how to run our own product. It is not just about taking some bits and applying it to servers and that's it. When you have to run Exchange at any reasonable scale, you have to worry about every single thing, including the network tap. There are so many people. In fact, there's people in the audience right now that obsess about the network NIC to a degree that I think would deeply trouble all of us. But we had to go learn about things which we never worried about before. I mean, the fact that there are some links out there that we have to watch like hawks because they're known to be quite poor in connectivity. I won't mention what part of the world because I made a promise to myself that I would not offend people in the audience this time around. And the other thing I should probably admit, last time I got a little bit of hot water for picking on a particular ISP. So I should probably apologize to the ISP that sounds like Scrumcast. It was just easy pickings. But they were wonderful. They're great as an ISP, as an interconnect. So the other thing I want to show you is, and this is going to tie into a point that I'll make later on. So that's our global network scale. This is a clever little thing that we built recently. This is a view of, it'll take me just a second to kind of show this. This is a view of every single country where users live that connect to Exchange Online. Okay? And the purple and yellow lines are by magnitude availability of the service in that particular country segmented to the users of that particular country. So a lot of things are happening in the background. A lot of things like we are going and taking all the data on all of our users connecting, figuring out which country they belong to, mapping it on here, and measuring that over time. So what I'm going to do is I'm going to play a little bit. This is an interactive visual. I'm going to play a little bit, and you're going to see a little pattern that I'm going to build on. Notice here how the lines deviate. Some lines are moving, some lines are not moving across these countries. Well, there goes one. There's a couple moving here and there. Yeah. So what's the meta point here? Oh, they got really active there. What's the meta point? And the reason why it ties back to the network picture. Now, if all that was important in the service world was Microsoft's capacity and Microsoft's ability to go run the servers that we had in our data centers, all these lines would be static at the same time all the time. Why? Because all we would have to do is to go run those servers. But they're not. Clearly, some of these countries are getting less availability than other countries. I'll play it again while I mention this. Why is that? It's because there are local factors that impact the customer experience that is way out of control, way out of Microsoft's control, and sometimes, in fact, oftentimes, it's out of the customer's control. But Microsoft's not going to give up on those customers and those experiences. So one of the things that I'm going to show you today, later on in the session, is how exactly we're going to try and solve this problem, which is try and triangulate the people who are having a problem and fix them, even though it's out of our control in our servers. So here's, and by the way, so I got this demo a couple of days ago, and it was really cool because I could finally see where all the users live. We don't have people from Sudan, not a surprise, but I was kind of surprised to see Yemen. And the other thing, and this is one I couldn't do in time, but we could even notice patterns in changes based on large geographic events that were happening. So we were able to see what happened when the Nepal earthquake happened, because the availability in that country shifted dramatically. So all this cool stuff coming up. Let's go back. Let's talk a little bit about data and monitoring, which is one of the big sections that Perry alluded to, essential to MTTR. Monitoring is a super hard problem. And you know it's a hard problem because I capitalized the word hard. This is a graph that shows our increasing scale by server count. That's the orange line. The blue lines, vertical lines, are lines of the alert counts that are going to the engineering team. So the scale is increasing. The meta point here is somehow we have managed to figure out how to be discontinuous with the scale of the system. Another way to think about it is we've actually managed to somehow increase the number of servers that we have deployed for Exchange Online without letting that impact the number of alerts that we see. Okay? Hold on to that thought. Of course, last month wasn't good compared to last March. I actually don't know why, but I'm sure we'll be on it. But it's overall lower than when we were starting out the service. So hold on to that point. We have somehow figured out to make monitoring easier and better, even though our scale is increasing. Okay, so how do we do that? We have stopped thinking of monitoring as just monitoring. We have converted ourselves to be thinking of monitoring as data analysis. No longer is it just about creating alerts, looking at alerts. It's about taking signals, building confidence, tying it to automation, and then using that automation to get out of the way of those recovery steps, get the humans out of the way. Fundamental to this is this piece of technology we call our Data Insights Engine. In fact, there's a collection of technologies. This just happens to be the coolest name for it until we find a better code name. 500 million events an hour, growing every day, millions of organizations being monitored, hundreds of millions of users, 15 terabytes of data being processed. Of course, this is very lightweight data. This is actually quite a bit for lightweight data. Dozens of data centers in many regions, dozens of components. Last time I presented this deck, we were 100% Microsoft tech. We were built on Microsoft Azure, SQL Azure. But very recently, in fact, in a month and a half ago, we started incorporating open source tech into our world. Precisely this technology called Cassandra, which is a NoSQL technology for streaming. One of the interesting trends that's happening in the monitoring world is people are leaving behind these super rich, deep, schematized databases and moving to more real-time assertion of quality and strength and confidence in data. The right-hand side is what I'm alluding to. It's two very randomly different pieces of data. The top is our availability metric, which is signals being corrected on how many users are connected and what their experience is. And the bottom is, it's related, but it's a very different metric. It's the number of people who are going and visiting the service health dashboard when there's an incident. Okay? So people who are impacted are going to the health dashboard and checking out this web portal. So we're taking all those clicks, and it turns out we can marry those two sides together, and we can say, wow, for example, the service health dashboard is a kind of a good indicator that there's a problem. Duh, because people are going to the service help dashboard when there's a problem. But normally in monitoring, you couldn't correlate these multiple signals together because they're radically different time frames, different granularity. But with the advancement of technology that we've been able to make with this data insights engine, we can now marry all kinds of signals all around the world to come up with an answer which is much more accurate than it was ever before. The big part of what we do in terms of monitoring is we create synthetic transactions for everything that is important. Each scenario is testing every database worldwide every 5 minutes, scattered, of course. So you have near continuous coverage for everything that lives in our system. From 2+ locations, 250 million test transactions. And what this does is it creates a very great synthetic baseline of what the system should look like. And then we can overlay a lot of other interesting things. For example, we can create a baseline comparison to that previous active monitoring signal of real usage over time. Real users compared to what our system should be doing. And that allows us to go figure out what the real problem is. Again, now we're trying to build onto this case of how do we go identify the users that are in trouble and fix them, even if they're not on Microsoft infrastructure. So the system that we've built handles around 50,000 transactions a second, over 1 billion user records per day coming in. And of course, these are user records as in little events that say the user attempted to log on, the user failed to log on. These are passive tests, not core user data. The big, I would say, innovation that we had was this concept of red alert. This is a thing that shrinks down all those monitoring signals from all those machines that are in our data centers and our many data centers down to something manageable by a human being. The concept is quite simple. The concept is the following. If something is happening across multiple signals, there must be something going on. It's kind of a duh statement, right? But you'd be surprised how many monitoring systems in the world are built off of getting to high confidence in one particular signal. Like I know if I go talk to a bunch of folks outside and I ask them, hey, what's your biggest monitoring problem? They'll say, well, there's this particular Outlook alert that's just always, or some machine alert that's always going off. I just want 100% confidence when it goes off that I want to pay attention to it. The problem with trying to build confidence in any one signal is that it's a fool's errand. It'll never work. There are just too many things involved in order to get high 100% confidence in anything. In fact, it's mathematically impossible. And if we need Perry up here again to explain it, I'll bring him up here. It is mathematically impossible to get to 100% confidence. So if it's mathematically impossible to get to 100% confidence, what people do when they try to monitor large-scale environments is they throw bodies at it. We're just going to let human beings go decide what's relevant at any given point. But that's also a fool's errand because you can't have enough bodies when you're managing 50, 60, 70, 80, 90, 100,000 servers. So what do? Concept is simple. If you have multiple things at the same time that are breaking, either you have a fundamental problem that is affecting all of them, or you don't. Very simple. So this concept of red alert allows us to shrink all those individual signals down to one thing that matters most. And a visual example is coming up in a demo. And this allows us to get to 100%, almost 100% accuracy. And I say almost because there's always opportunity for bugs to creep in, but almost 100% accuracy. So powerful that we don't have 24/7 staff watching our monitors. All we have is the machinery that wakes up in the middle of the night if it detects a problem and pages the right on-call engineer, or more often, as is the case, it just goes ahead and solves the problem. So no human beings are staying up all night watching monitors just so we can monitor, just so we can take care of the service. Okay? Core concept. Now, the other thing that we can do once we start having these signals and building these red alert signals off of them is that we can start triangulating across all of our partitions. So one of the most frequent things that I get asked is, well, fine, you created a red alert, but if you must have a red alert that just goes off of every single event that happens in your service. That's not true. Or a red alert is so aggregated that it's not actionable by a human being. That's not true either. And the way that this works is, because our capacity, remember, is broken up into little chunks, the combination of many signals mapped to many little chunks lets us go figure out which one of those precise chunks might be having a problem. So here's an example of an alert that goes to some of our teammates. It tells us, based on the combination of the red alert and the combination of the failure events, exactly which components could be having a problem. In fact, not just that it could be having a problem, that we're going to try and fix that problem by ourselves. So for example, restarting a mailbox server. And this lets us do some very clever things at large scale. If you were to visualize every one of these signals, red alerts, coming in and being mapped over all the partitions that we have in our service, and you perhaps look at it over a time scale, left to right is time scale, very simple exercise. What we discovered is that there's these obvious patterns that emerge when there's a problem. So instead of us building every single monitor for every single scenario, hooking it up to every single server, we kind of take a step back and we map all of this stuff at the very high level, all these signals, and we look at these patterns. Now, any intelligent human being will say, boy, if something is read across multiple partitions, it must be a problem which spans multiple partitions. In fact, that's what allows us to say things like, hey, this is a networking problem that's affecting multiple data centers or multiple DAGs. Or it's org ID or Office 365 identity system that might be having a problem. Very quickly, it gets to the source of truth. Now, if something is isolated, even within that isolated chunk, we have multiple partitions. So we can play that same trick over and over and over again. You can get down to the server level. Multiple servers having a problem versus individual server having a problem. Super simple math that lets you go figure out what's wrong at any given moment. Now, this is my like, Perry mentioned the word machine learning a couple times. I know people are really proud of like a lot of machine learning stuff happening in the industry. This is like my primer for people who want to be able to, over beers, impress their friends on what machine learning is all about. Okay, everybody ready for a little quick becoming a PhD in machine learning? Yeah? All right, so this is how it's going to go. I'm going to give you a visual example, and we're going to map it to this slide. And after that, everybody will be machine learning experts. All right, imagine left to right, there's a signal coming in, up and down, up and down, up and down. And so imagine that you have a pen, and you're drawing that signal. Okay? You're drawing that signal on a piece of paper like this. You're drawing over and over and over again. You're drawing that signal. If you do that enough times, you don't go back and erase any of those lines. When you draw that signal over and over again, you get something that looks like the light gray, or the light whatever color that is, light gray in that chart. Why? Because going over the same area over and over again, drawing that same signal over and over again, is the cumulative value of all the values that have been seen by that signal over time. So those are the expected values over time. Now, what machine learning does is that it does that repeatedly against a known healthy set. This is a training set. Okay? Now, when you take a new signal, or a new signal that has not been seen by the system before, and you map it against that gray, anything that doesn't show up in that gray is what? An outlier. Is an abnormality. And that is what we use to go flag things which might be odd. Super, super simple. Who feels like a machine learning expert now? All right, one guy. No, two people, three. All right. This is what statistical machine learning is all about. It is about taking expected value over time and then mapping the new signal on top of it. Anything that doesn't show up in the gray area is an outlier, and you flag that as being abnormal and follow up on it, or you trigger an alert. Super simple math. So, combine all these things. What have we been able to achieve? When an alert goes off, let's say 4:46 p.m., alert was raised. At 4:46 p.m., we're able to go, because we have 100% accuracy, confidence in our data, scope, we figured out where the problem was. We go ahead and auto-post to the Service Health dashboard. We go tell customers directly what the problem is. In fact, I brought on some stats. So the left-hand side is the posting in minutes of a red alert versus a non-red alert case. The blue is the red alert case, average over time. In 32 minutes, we're able to go post. And this includes the beginning of that incident, even before the alert was raised or not. And the right-hand side is the number of customer cases. This is the stunning one for me. So the customer cases, this is the number of support calls that we get during incidents. Blue is what the number of calls are when we issue a red alert and the auto posting versus the non-red alert case incidents that have happened in our system. Dramatic difference. Another way to say this is when we go figure out the problem, we post it on these health dashboards and we fix the problem, people don't call us. And that proves Perry's point, is using the machinery, the machine learning, machine learning, double quotes, the MTTR recovery techniques, we're able to dramatically shift the user experience at massive scale. All right, so let's look at a few more eye candy demos about our data systems. So the next one I'm going to show you is kind of an interesting take on the red alert. So this is production. This is actually production right now, or whenever I took that screenshot, or not screenshot, loaded this page. The red line is the red alert line. Now the red alert line, remember I said it takes multiple signals, combines them to figure out what's wrong. What the red alert line is doing is it's taking all those other lines and creating a composite function. And this is a logarithmic scale, by the way, so it's not like anything's actually bad. In fact, the availability on average across this time period is probably greater than 99.95 in my estimation. In fact, across our data centers, it's doing quite well, with the exception of LAM, which could be one of those network links that we saw earlier. That was red. But the clever thing about this red alert technique is that you can use it to go do a couple of other interesting, and of course, this is still, remember, logarithmic scale, so don't be worried that the Exchange Online service is freaking out. You can use it to do a couple of other clever things. An example of that is, remember when I said that it's a composite function, so it represents more than what's going on in any one particular place, and that there's a little machine learning technique which allows us to say what's the expected value versus known value? Well, you can do some very rudimentary math to get even better. So imagine that you were to draw a line from every one of these points. If a curve is leading up, the line is going to be going up, and the top of the curve to the bottom of the curve, the value is going to be positive when you do a subtraction. If it's going down, if you do the same math, it's going to be negative. Another way to think of that is very quickly we can quote-unquote predict if the curve is going up or down. That allows us to alert faster than normal than human beings can possibly tell. As soon as the curve starts shifting down, that little math that I just described just says, hey, we're about to hit a downtrend. And the faster that line, or the bigger the numerator, or the bigger the value is, it tells you the faster the curve is decreasing, which tells us, boy, we have a really big problem. So this red alert concept lets us go alert rapidly fast. We don't have to hit a threshold. Every monitoring person that I've ever talked to who's an expert in monitoring has this idea of thresholds. In our world, if we were to set a scary threshold, by the way, it would probably be like at 99. But we don't want to let the world get to that bad before reacting. So how do you stop an alert well before it gets to 99? Well, you look at the shape of the curve. So machine learning, which is really expected value from the internet value, looking at the shape of the curve, composite function, lets us monitor thousands and thousands of servers, thousands and thousands of entities with a few human beings all combined together. So let's do a little bit more spelunking in this view. One of the interesting things we added recently is this idea of client signals. So what you saw earlier on the previous visual was all of our synthetic transactions that I mentioned earlier. This was all the tests that are quizzing every database saying, are you healthy across OWA, Outlook, all those scenarios. Now this is an example of us taking what we would call passive signals. These are signals that are an after effect of users logging in and using the service. Okay, so you're a user, you're using OWA, you're logging in. All that signal comes back to us. We can open it up, and we can see some pretty clever things. We can, again, use the concept of triangulation. Here's a good example. Let's click on platform. We could predict, for example, based on the concepts I talked about, that Windows 7 clients are having a problem, or that Chrome clients are having a problem, or particular browser clients are having a problem. I don't think it's a surprise to say Chrome is pretty popular. OA renders quite well on Chrome. Let's just get rid of Chrome for now. I think I saw an Edge browser in there. I think it's MSIE 10 Plus. Look at that, already very popular. Not bad. And at the same time, if you think of every one of these pivots as being individual things that we can slice and dice with, imagine combining browser, version, geography, user set, physical servers. You can pinpoint exactly who in the world is having a problem with OA using this set of techniques. And of course, for the development team, we also tell ourselves what particular errors could be happening. So you know what the very particular problem that could be introduced by code or a, God forbid, a regression into our system. The other thing I want to show you is some clever work that our networking folks have done. Again, think about the complexity of that network chart that I showed earlier. That is enormously hard to diagnose in a day-to-day incident. So what we did is we went and interrogated every single network packet that's coming into our system, and we classified it based on the ISP. And of course, I have to be careful not to offend somebody again this year. But there are particular ISPs that don't have necessarily the best traffic back to us. And the reason why I'm taking out other unknown is not because that we don't have the data. The number of ISPs in the world far exceeds the ability for us to visualize it. So the long tail, we've just made other and unknown. The top 30 are represented here. So here's an example. I think this is Microsoft's own backend network. Cogent, Charter.net. What the networking team has been able to do is they've been able to take every single packet coming in, interrogate it, and map it into the same framework such that now we can identify a particular ISP, a set of users behind that ISP, the particular version of whatever browser they're having a problem with, the particular users using that particular browser version. So now we have that entire stack mapped out on who the particular user is who is having a problem. If it's an ISP that's at fault, this will alarm and raise the central alert to us. Sometimes we wish it would do that faster because sometimes it's a long-tail ISP. And we will go engage our networking team to go call up the ISP and to fix the problem, to fix our users up. So this goes back to what I was telling you earlier. Our job is not done until every single user is happy. Using this data and using what the philosophy that Perry talked about, we're able to go triangulate the number of users, exactly which user, what browser version, what client version, and drill down and fix the problem, even when it's outside of our control. Now I want to show you something that a few folks in this audience actually have been working on, which is kind of cool. And I'm not going to do this scenario justice. But just like we have been interrogating all the signals that exist outside of our service, users and transactions, we are also taking all the instrumentation that tells us what particular code or code pieces are either misbehaving or have opportunity to be improved over time. So the way to read this is all the, and I have to be a little bit careful in describing this because some of this tech doesn't actually exist outside of Microsoft, and inside Microsoft it's just becoming kind of nascent. It's quite powerful. So the way I should describe this is, imagine every server running a bunch of code. Yeah? Not complicated. Every one of those servers doing unique work on that server based on the users and based on the load. Okay? So far, so good? The baseline software on all those servers could be the same. So the developer version that we've sent out to everybody is the same. So for example, MS Exchange or Edge Transport is running on a whole bunch of servers inside of the Exchange Online topology. Now, as a developer, when you're coding, how do you make sure that your code's going to work performantly, with the right performance, with the right latency, with all the behaviors that you want in production the way that you expect? The answer is you're not going to know that unless somehow you had the ability to take all the data in production, map it back to your work. So that's what we did. We took every single process, every single error, and classified it. And this is like billions of data points that are coming up from the service. And of course, this is kind of interesting. You can go see, and this is not going to be a surprise to a lot of people, but the most common or the most prevalent exchange process that is consuming memory in our online service, and by the way, 10% of all memory in our online service, 10% of all our servers effectively is the Exchange store worker. And the reason why this is interesting is every one of this, I'm sure the store guys are like, why are you picking on my process? Well, because it's really important and it's running everywhere. The really interesting thing that we can do now is, remember, if you're aggregating this across hundreds of thousands of machines, every little percentage point matters. So if you wanted to somehow hypothetically save Microsoft a lot of money, you could go in here, you could calculate every one of these percentage points. You could find the ones that you could decrease by changing the code, change that code, and you could see, like Perry would say, millions of dollars just appear out of nowhere. But more importantly, this is about us being able to scale by allowing our developers to be proficient with all the information that they need at massive scale. So every single data point on every single piece of code that's running, funnel back to the developers. Just like we're talking about signaling, creating signals for users, we're doing that for our own machinery and our own code and engineering. So that's a quick breeze through all of the ways that our data systems operate. I'm going to switch back and talk about the next big innovation when it comes to running Exchange Online, which is really our automation systems. And that graphic is in jest, but it's also reality. We literally are turning into robots, as Elon Musk has predicted. The way that work gets done in Exchange Online is through what we would call a meta-system. A meta-system is a system that exists purely in the purpose of other systems. So we don't have automation that runs uniquely just on servers. It does. We have lots and lots of automation that uniquely runs on servers. You have to create deployment automation, reboot, all that stuff exists on servers. But in order to manage hundreds of thousands of machines, you don't just need those servers. You need meta-systems. Central Admin is our meta-system that takes all the workflows that we need to go run at massive scale and executes them in the right fashion, at the right time, with the right directive from the engineers that are running the online service. Last time I presented this slide, we were at 50 million workflows, which was a pretty scary number. Now we're up to 200 million workflows. Of course, this is scaling with our number of servers. The scary thing is, boy, I don't think there's an end to the number of things that we need to go get done. Think of this as the following. All the servers that we're managing, they're probably being operated on hundreds and hundreds of times in an hour every single day. Now, that's kind of a scary thing to tell an audience full of customers. But yes, the truth is that these things are being managed, cleaned up, maintained, and you should kind of feel a little bit of confidence in that, because the things that are left alone drift, and they get worse over time. On the top, maintenance is what Central Admin does at very large scale. One of the central concepts that Central Admin does is the concept of orchestration. This is an important slide. Orchestration versus automation. It is stunning how many folks think that automation is the same thing as orchestration. I'll describe why I want to point out that orchestration is a more powerful concept. So today, when a piece of code rolls out, it rolls out through multiple safety rings and steps, right? So ring 0, feature teams. The engineers who built the piece of code get to enjoy the things they built. Perhaps the entire Office 365 team, not just the feature team. Microsoft, goes to a set of customers, select customers. I think many of you are in the first release program. And then eventually goes out worldwide. Now, this is like the rosy picture. This is like the everything goes well. There's like marketing art that tells you how awesome it is. But what if at any one of these points a disaster struck or there was a problem? Now, can you imagine the number of changes that we're making every month, all these new features that are being added? How's that stuff all managing to roll through all these complex rings? In fact, simple rings, I would say, but complex steps and happening at scale. That's what I mean by orchestration versus automation. Just being able to do something without a human being is automation. Being able to do many, many things, stitching them together to create one scenario is orchestration. And orchestration is the bigger key to success in online services. So the more important orchestration that we do on a daily basis is what Perry alluded to earlier, which is new capacity deployment. Not only shifting code through our servers, but also taking servers out for readiness from our pre-rack stage all the way down to serving customers. I'd love to be super proud of this methodology, but Ford invented mass industrialization a long time ago, and everybody else has been just copying him left and right since then. This is a concept that the Japanese have invented called Kanban. How many people know Kanban? Yeah? Actually, a lot of people know Kanban. Okay, so we've implemented Kanban. But we did it in a way that no people actually have to look at cards. It's the machines that look at cards, which is kind of scary. But at the same time, it's also cool. So I'm going to show you an example of what Kanban looks like in our working service. This is an updated chart as of maybe a couple of weeks ago. I would have thought that hard drives would have been the biggest replacement, given how intensive we use them and how important data is to Exchange Online. In fact, the entire premise of Exchange Online is data. But surprisingly, disk controls are still there, but NICs and what we would traditionally call software failure are coming up as being the predominant things that we fix in our system. So disk controller, that's the big yellow one. NICs is the green one, and this is why I alluded to earlier. There's people who obsess about the quality of our NICs just precisely because of this point. But software failure is an interesting one. More and more now, we are modeling all failures not just as hardware, but also as a combination of hardware and software. And we have built some very interesting systems that allow us to go deal with both software and hardware at the same time. So we built this thing called RepairBox. In fact, a lot of our code names end in box. One of the ones that we announced earlier a couple weeks ago, how many folks have heard of Customer Lockbox? It was announced a little while ago. Yeah? I don't know why it ended in box, but RepairBox is this mechanism by which we scan the entirety of our service and take proactive or healing action. And one of the cool things about it is it doesn't just focus on hardware. It also takes care of the software problems that are happening in the system. Most traditional IT tool sets kind of separate the two things out because they kind of think of hardware and software as being two logically separate things. In our world, issuing a ticket for a hardware request, which should be automated and taken care of, and issuing a ticket for a software fix being a updated deployment or dealing with a straggler, something left behind, is morally equivalent. And that has led to us having metasystems that operate very cleanly across all of our online capacity. And the great thing about this system is that engineers can invoke it directly. You can issue a RepairBox request. It'll go off and execute it. It'll come back. It'll ask for the right permissions. Remember, that's orchestration. Automation is just being able to automate something and to do it mechanically, but orchestration is doing it through a logical set of complex steps. Takes care of all those actions without any intervention by a human being. So let's see a demo of some of that work. And I'm going to go ahead and use the same console that I was using earlier and show you a more complex orchestration that's going on in the system right now. Again, this is live production data. I don't think there's anything here that is super secret, maybe mildly secret. But this is a list of all of our builds. So think of all the code changes being deployed as being a build. So these are all of our builds that are being deployed in production at various stages. Some of them have failed, and by the way, that's not a bad thing. There's nothing to be embarrassed by if a ring has failed. That's a good thing. That means we detected a problem. In fact, if I click on one of these build failures, it shows me all the sequential tests that it's running, and if there's a problem, it goes ahead and automatically fails that. And like I was saying earlier, a lot of our code names begin or end in box. The component called FuseBox is a set of fuses that go off in case there's a problem. Will protect the end user as these builds are progressing through these rings. So this is an actual implementation of that nice marketing design diagram that I showed you earlier across all these environments. And of course, these builds are also being generated by very impatient engineers, I would say. Very, very impatient engineers, very, very, very impatient engineers. And so sometimes orchestration is not just about being able to do things at massive scale. It's also about just letting, telling the engineers to shut up and just go back to their work because we'll take care of the rest. And that's kind of an interesting aspect of running at scale is the need for change never really, really reduces. Continuously, we're being asked to do things faster and faster. So let me show you another aspect of changes. That this is fairly new code. It might be a little bit buggy, but in the essence of transparency, I hope you won't mind. One of the problems that we've heard from customers is that, hey, Microsoft, you've done a good job. You're running these massive data center systems, all these servers, but how do I have confidence that you're able to track all the changes that you're making? And the answer up till 6 months ago, 7, 8 months ago was, unfortunately, trust us. But we're able to do better than that now. So what we did is, the same way we were able to take all of our data systems and hook them up with our monitoring systems to create better insights, we're able to do the same thing. So here's a particular tenant. This is Microsoft. I'm going to show you all the changes that happen for Microsoft in our service infrastructure. Great, that return. Now here's interesting. Like this is the number of physical machines that are being impacted by whatever changes that might be happening. Now this is a shared environment because the other tenants could be also impacted the same way. But I'm able to go drill down, and this is a key point. Like what other service provider is able to do this in a shared environment? I'm able to drill down by a customer on all the changes that are happening in the service infrastructure for that customer. All right, so let's take an example. So, of course, this is a Microsoft tenant. So there are some things that normally you wouldn't see. I think here somebody says, blah, blah, I'm creating probably a distributor group for an Ignite demo. Great guy. But let's check one that's a little bit more interesting. Here's a code deployment that's going on. Here's something clever. Not only do we know the deployment that is happening through those rings, now we can go figure out what is the delta in the code between one version that's already in the system and another that's being landed to production at the same time. And of course, this is very early code. But if somebody was, for example, in an incident, they could go figure out the likely place a problem has happened based on the monitoring signals that I showed you earlier. You could click on a component, and then you can go drill down and see, hey, who are the engineers who made what changes for what time that might have affected Microsoft on Microsoft.com. So a very powerful technique to allow us to go rapidly figure out what's happening in our system at any given point. The interesting thing is we're able to, the next logical step is, why wouldn't you just take this change data and correlate with your monitoring data? And that's exactly what we did. This is a very new test interface. This is showing all availability, a bunch of incidents or not incidents, but a bunch of synthetic tests and transactions happening through the system. And if you notice a little bit below, it's able to tell me at key points that it's highlighting in the chart changes that have happened. So for example, if there was, God forbid, a dip in availability, we could go find the previous change that had happened right before then, highlight it, and then go figure out who made the change, what the change was, and if we needed to, go figure out if we needed to go do something about that change. So tying data systems, our machinery systems, automation all together to make it really possible to go manage at a large scale. This is an interesting new tool that we built. The big advantage of this one versus the other ones that I was showing you is that it scales incredibly well on a mobile device. And for a bunch of nerdy engineers who like to complain about, oh my God, why can't I use this at home? This is just magic. Okay, so now we're going to go back and show you the last little piece, which is about secure operations. This is a piece that I can guarantee you nobody has seen before. And probably for good reason, because we have maybe some of us believe that security through obscurity is the right way of managing ourselves, but I'm not one of those believers, and I'm happy to show you a little bit more detail in transparency. So I'm going to take it a little bit light on this because I don't think it's about really the philosophy. The essence of this is we take a lot of time to go figure out how to go run the service well. Perry, Perry's peers, our CVP, Rajesh, everybody sits down monthly to go review the entire service up and forward. We figure out what the problem areas are, and we go drill down and make sure things are working better. Our operations model is quite different than what you would expect on premises. On the right-hand side is you see what we model in our own organization. The essence of it is we don't really have operations in the traditional sense. We don't have all the alerts going to a central operations body that go act on them and then go figure out how to go find the right person responsible. The right person responsible is engaged at the first go right away, cutting out all middle people. And that's been really, really important as part of MTTR. But we do think operations is important. There are dedicated functions where operations is quite important. The Kanban slide I showed you, boy, I cannot convince enough engineers to go work on that. Why? Because they want to go back to writing code. But there is a complex project that needs to be managed. So we have really, really smart engineers that go work with data center managers all around the world to go deploy hardware and servers efficiently and aggressively. And so we have dedicated operations for that. But outside of that, we don't really have an operations model that works in the traditional sense. Everybody inside of our service is on call. And that means myself, folks like Perry, the engineers in this room, some of the engineers in this room, PMs, everybody is on call. Team managers are expected to be the folks that are responsible at any given time. We even have our VPs on call. This is a little bit of a chart that shows you what the impact is of people being on call. In general sense, it's quite good. Not a lot of people spend more than 50 hours a week on call, but some of them do. The table's kind of interesting. I pulled this just recently, because I wanted to be super transparent on what people think when they're on call. So the first quote is interesting. It says, "When I am on call, I hate my job and consider switching. It is only that I work with great people when I'm not on call." The irony of the situation is, of course, when they're on call, they're also working with the same people. But in this essence of transparency, it is a hard job. And this is why people have had dedicated operations for a very long time. Because it's easy to shovel work that's really hard off to a central body and make them feel the pain. But in the model, in the Microsoft model for running services, everybody feels the pain. And that's important because that's the only way we will get better. And this is what Perry alluded to earlier. I actually have a picture of one of our VPs because, this is a stunning thing. When you put a senior person on call, they're very smart. They figure out how to look smart in the worst situation, even though they have no idea what's going on. And I'll tell you the secret. You can repeat this exercise. If you want to look smart during an incident, just do what one of our senior VPs does. I don't know what's going on, but has anybody talked to the networking team? The answer is yes. The answer is always yes. All right, so very quickly, I'm going to show you something that I hope you find a little bit comforting when you think about what Microsoft does and how Microsoft operates. So remember when I said that, or where Perry said that the only way we can scale is by intermixing risk, cost, and a whole bunch of these variables? He's absolutely right. So I'm gonna actually log into one of our systems, and you'll notice a couple of things. One, I am not using terminal services to go log into our data center. This is remote PowerShell. I'm going to open up a separate window on the side just so you can kind of compare the two. One is connected to production. One is connected to our Dogfoot environment. It asked me a couple of questions on what site to use. And then it asked me about, hey, where's my smart card? I'm going to go ahead and put in my smart card. Hit OK. And then it asked me for another set of credentials, 2 credentials. And by the way, if I lock my computer and I use my regular Microsoft password and not a cert-based smart card auth, this will not work. Right now, I'm not going to go do that. I've already demonstrated I can do that. OK, and cancel. Get out of it. I'm going to go to this production one. This production one I opened up a little while ago. OK. I'm going to hit enter, and I'm going to type in a command to see if I can get some work out of, or I'm going to engage with our service live. Let's see. Let's just do this. See what happens. This is like something very clever happens. Even though this window is open, where it is connected to our production environment, you notice how there was a little bit of a gap in time where it was trying to figure out what to do next. But what it was doing is going back, is checking all the local certs that I have, is checking my multi-factor auth, it's figuring out if I'm the right individual, and then it's letting me into the system. Two things you should take away from this is, one, while this looks a lot easier to get into a data center and manage the service than what you would imagine, that's a good thing. Why? Because the next easiest step is a lot less secure. Most everybody who's managing critical customer data is logging physically onto those servers. When I'm in this interface, this is only exposing me to a limited set of things that I can do. I never am physically interacting with the service. And if I am needing to go get to customer get to customer data, or if I ever have to go do something that might be a little bit more invasive, I have to request elevation. And by requesting elevation, a request is sent off to my manager or somebody in my chain of command to go approve before I'm allowed access. And that access continues to be logical, never physical. It never gets me to a point where I have accidental overexposure to the data that are in our customers' hands. And this is what enables what Perry talked about, is management at large scale, at ease for our engineers, without all the scary complexity and the unnatural act of logging onto any physical server at any given time. So I'm going to switch back with that and finish with one last thing, which is, we're at time. We want to continue this conversation. We actually like it to be super transparent. Perry didn't know that I was going to have this picture up, by the way. It's really good to have friends on Facebook that have friends on Facebook that have photos of people that you're presenting with. We really want to make this a conversation. Yeah, take all pictures. I mean, I would love it if what do you call it, tweetosphere? Twitter, is that what it's called? Twitter? I'm joking. Twitter, yes, please tweet this. We would love for this to be a conversation. We love talking about what we do. We love having a transparent dialogue with our customers. I really appreciate having Perry, you guys having attention span for Perry and I to talk about how we run online services. There's a couple of things that I'd love to show more, but what we'd rather do is have you tell us what you'd like to see next. But I think we have enough time for questions, and we've got some swag to give away, so I'll invite Perry back up here, and we'll hopefully be able to answer some of your questions. Thank you. Where the fuck did you get that? One minor thing. There's a new book, Office 365 for Exchange Professionals, that our dear friend Tony Redmond has written. That's going to be free copies at the Bumps and Blimps session. And that's not like I don't think Tony was bribing me by having me pimp his book. But I'm sure it's a great book. And you're all welcome to a free copy at his session tomorrow, or on Thursday at 1:30 p.m. So any questions or any comments? Yeah, go ahead. There's also like mics back there so that folks can hear. But go ahead, yeah. So the question was, the orchestration piece that we showed, is that based on Microsoft Orchestrator? Unfortunately, the answer is no. Because many things at this scale just don't work as you would imagine. And that's the difference between on-prem software and cloud software. On-prem software is very schematized. It's built for plug-in, play, and even that it's complex to deploy and use, sorry to say. But large-scale operations require some specificity, which is not possible in some of those products. However, as you saw, we are a lot more open with the open source community, ironically, and that's been very helpful in that regard. That's a good question. Go ahead.
So I have a question. It's multi-part.
Okay. For Perry, probably, right? Yeah.
Sure.
Okay.
So going from on-prem to the cloud is a big decision. And you kind of cannibalized your licensing in going to that model. So my first question is, has that been profitable for Microsoft? Is the person who made that decision still working at Microsoft?
So it was for Perry.
And because you did show, 50,000 repairs, hardware repairs being done on an annual basis? So it's an expensive, we're just curious.
That's a great question.
Working?
Okay.
Yeah. we're feeling very good about our shift to the cloud in terms of our margin story. If you think about it from a margin percent thing, we had a dramatic reduction in our margins in going to the cloud. But before, we were selling cardboard, and for many people who were on our EAs and so on, we're selling, electronic downloads. That was the COGS side of things. So the percentage of our revenue that is COGS has risen dramatically. But if you think about the expansion of the value proposition we've got, the old exchange business basically boiled down to gross revenue of 80 cents a user a month over the lifetime of a business user. That was our gross revenue bit. Our customers would then turn around and spend $10, $20, $30, $40 a user a month to run their service, buy the hardware, pay the people, do the support, right? So we were extracting a tiny fraction of the total value proposition. In this new world, our COGS are up, but also we're capturing a much higher percentage of that value chain by reducing the cost to our customers a lot. So the amount of margin per user after customer acquisition costs is actually risen pretty well. So we call that the enterprise value of a seat, and that's gone up pretty substantially. And then the other part of it is the number of people around this planet that are addressable to the service and to Exchange now is dramatically improved. Exchange was just too expensive for really small customers, and plenty of businesses in third world countries or so on, it was just priced out of the market. So we think the addressability in terms of numbers is way up. And our absolute amount of margin per seat has gone up. So yeah, if you look at the earnings a couple weeks ago, you could say that we're having some interesting challenges in transforming some of our businesses, but the vote on our stock that occurred after that, based on the progress we've had in transforming our productivity desktop service to a service model, is the thing that people are feeling very bullish about, and I think we're feeling very good about that bet.
Thank you.
Great question. By the way, you can get a shirt for asking a question. I forgot about that.
That's right. If it's a good enough question.
Oh yeah, if it's a good enough question. That was a good enough question.
So I've got another question. Where the hell did you get that photo? I didn't even know that photo existed.
Hey, if some of us are clever enough for running 100,000 servers, I think this is a small task. We put orchestration on it.
All right.
Go ahead.
I have a couple questions.
Yeah, please.
How do you handle all of the hardware repairs? Is it physical bodies replacing hard drives, pulling that green section of the pie chart for the NICs?
Right. Well,
Go ahead.
You can answer the second part. I think the first part of it is we don't need to handle it in real time.
Right.
Yep.
Right. So most of it can be a batch-oriented model in which people can go through these large data centers and do it very efficiently. Right. There's a large number of hard drives to fix, but they can go through in order in the data center instead of going and finding a particular hard drive and fixing it in the next 5 minutes because something's down. So our first step is nothing's down, and you can come back over the next 24, 48, 72 hours, whatever the SLA is, and that can match to the amount of the rate at which the hardware is failing. So the overhead of doing that is very low.
So Tuesday's hard drive day and Wednesday's fan day.
It can literally be that.
Yeah.
And that there's a relatively small number of people involved in doing that hardware. And they're not diagnosing. They're literally, the machine's off, and their ability to screw things up is very limited.
By the way, Friday is Blue LED Day. But to answer your other question, yes, there's still human bodies involved. We call them carbon-based systems because they're people. Yes, they're people. They do a great job. We are deeply appreciative of them. But their job gets a lot better on two fronts. One is the model for repair and spares that Perry's talking about, operationalizing that. But the second is working with the vendors and hardware providers to create local capacity in each data center on the individual parts and pieces required. So we don't do necessarily entire swap outs. We go target and fix those pieces as they require. In fact, Matt Gossage is one of the experts on I would say the back-end server role in general, you can ask him about how hard drives work in this repair model. It's actually quite interesting how much spare capacity you have to build in the data center just to be able to address the failure rates that we see. But that's the other way of doing it.
That's great. The second question is, I'm running Office 365 on my phone. Can you show me my account in your system and how my quality of service is? And you can't.
You did opt into that, so I'll show you privately. I won't show that in front of all the other people here. How about that? Is that okay?
That's great.
All right.
You.
I'll show you your availability privately. Yes. It's going to be awesome. Everybody.
Can we all line up for that? Just one by one.
Go ahead.
No, so the thing I was curious about, a little less on the support side that you kind of focused on, but you showed a great ability to sort of correlate changes being made to the tenants.
Yep.
And as my team, we've met with our TAM or account strategists, all these people, and one of the things we really beat them up on is the visibility to change that is upcoming.
Yep.
Like literally just today, we were, my
UX
team lead and I were there, and video showed up in our tenant today.
Yep.
We're itching for the EMM stuff to hit it.
Yep.
So where are we in terms
Yep.
of more awareness to enable our change readiness efforts? And
I love that
things?
question. We are announcing, in fact, today we announced a bunch of capabilities. Can you raise your hand, Raj? So that's the person working on rolling out an ability for our customers to have visibility and control into the changes being made to their tenancy in terms of end user features. Mm-hmm. You folks should connect. Raj, if you could raise your hand again if other people have the same question. There was a session given on it. And we're happy to go address that. But yeah, that's exactly right.
But we're philosophically committed to the idea that you are going to get notified. You're going to have the ability to have control over things that are in any way disruptive.
Yep.
And we're learning too about what it is that is disruptive, and the capabilities are increasing pretty rapidly.
Right. Yeah. So part of it too is just even little stuff like when it changed from the button-based UI to the banner to the button.
Absolutely.
Right?
You guys. There's a set of things that should give you warning 6 months, 3 months, and then in the immediate time frame, making sure that you guys have got are well understood that it's coming and or have the controls about when it gets turned on.
Yep. That's a great question.
Thank you.
You have one?
Hi. At MEC last year,
Yep.
I believe it had been released that for Office 365 that you guys run the CAS role on separate servers from the mailbox role. Is that still the case?
Yes.
Are you continuing along with that with the
Yes.
E16 rolling forward?
Yep.
Same case.
We fundamentally think that the scaling models of those two things, one's a completely stateless load balance system, and they have a different scaling law than the back-end user partitioned store. And that's basically what it boils down to.
Cool. Do you
Okay.
guys run them on the same, both roles on the same model or version of hardware, or do you
No.
run them on?
No.
No,
Yeah.
because one's a hard drive intense system and the other one's doesn't need hard drives.
Okay.
Yep.
Thank you.
Great question.
You mentioned that you don't have people watching dials and alerts proactively. It
Yep.
seems like it's a system that acts on it and alerts you guys. Was that a scary transition? Has it always been like that?
That's where we started.
Yeah, in fact, we started with that design principle from day one. So I don't think we know how to do the other thing, honestly. The other thing would be more scarier.
When we first jumped into this space, there was some set of received wisdom. One of them was you'll fail. You can't take an on-premises product and turn it into a cloud stuff. But I think one of the key bets we made was right from the beginning, the developers had a new job. You're responsible for the quality of the service, not just the quality of the code, which means when you write a feature, you're responsible for the monitoring and the response to issues and the decision about whether or not something involved human beings needs to get involved. And you're going to get reviewed on the lack of human being intervention if something is down. And you're going to pay the penalty in terms of your own sleep deprivation if you have too much either alerting or too little quality. So we felt like the feedback loop was kept tight and that we weren't going to build new features if we were too busy tightening up that loop. So we felt like the natural feedback. So that was a decision 7 years ago. And so the service has grown as that's going on, and that alert rate has kept constant, even though the scale has doubled or quadrupled every year since then.
A few people might hate their job, but doing on-call only, don't worry.
Right.
Yeah.
One of the interesting things about that was, the other thing with received wisdom was, as soon as you do that, all your devs are going to quit. But our internal measurements of team morale actually went up. That's an interesting discussion about what that was about. But
Everybody has a speculation on that.
yeah.
Yeah.
Thanks.
Yeah, great question.
Hi, good talk. The first question might be a dumb question, but is dedicated pods still a thing? And if the answer is yes, how does any of this scale down to something that small effectively?
So yes, we do still have a dedicated offering. The implementation internally we call D on MT. So you can think of it as, for a set of customers that are quite large, our minimum pod size actually approximates many customers who are 10,000 seats and above. So it's just a multi-tenant deployment. It just so happens there's only one tenant that happens to be in that set of hardware. You can think of it like there's a hotel that's a multi-tenant hotel, and somebody has rented the whole hotel for the next 3 years.
Beyonce, she does that regularly.
Right. So all this infrastructure comes to bear. You don't have to make a choice between the benefits of a public cloud with any of the benefits of having a dedicated hardware. And one of the benefits of dedicated hardware isn't the isolation of the hardware so much as you can now say, hey, can I have some control over update periods, which we can't give you if you're sharing that hardware. We can't take the risk of not applying a security fix because one customer within a hardware partition has decided that there's elevated risk to that company during the next 2 weeks because of a quarter end or something. Okay.
Thanks.
Great.
Do you do that with the other Office 365 products?
We do it for SharePoint.
Link as well.
And Link.
Yeah. SharePoint and Link.
Was my question good enough to get a T-shirt?
No.
Good try, though.
How about a copy of that book?
Yes.
Yes. You just have to show up.
You can get a shirt. Yes.
Is there a future with Office 365 and whatnot, like Nano Server deploying Exchange as an app, per se?
You mean, and by Nano Server, the very lightweight Windows Server stuff? Yeah, we are taking a hard look at how to make sure that Nano Server meets our needs, because there's benefits in terms of minimizing the footprint we've gone on. So had some interesting conversations with Jeffrey Snover about making sure that it's a good fit for us in the long haul.
Yep.
So given the economies that you guys see in the scaling you have and the intelligence that you build in the system, do you ever see a future where it just doesn't make sense to have on-premises?
Yes.
How far out do you see?
Now.
There's still a lot of people that are very nervous.
Yes, there are people who are very nervous about it. So the conversation that we keep having with people, I think we convince people about the cost thing. We convince people about the user experience, because most people are like, well, the code you're running today is a decade old, so moving to the cloud is just better from the experience perspective. And then they go, okay, now my risk profile. I can't move to the cloud because it's the cloud and my data. Okay, well, do you have people in your employment who have domain admin privileges right now? Yes, you do. Fascinating. Okay. You recognize that if their credentials leak, you're done for. Okay. So your risk profile in the cloud is better because we don't right now have anybody.
Do you have anybody with persistent large?
No. Zero standing access is the position. If you take my credentials right now, you can do nothing.
Yeah.
If you manage to spearfish me, you can do nothing. And I am on call.
Did you do segregation between administrative account and non-administrative account because of that? Or do you just say, my account only gets admin when I need it and I don't care about it?
I'm not sure I quite understand the question. There's a very limited set. Anybody who's working on the surface has got a role. Okay? There's a set of things that they can escalate into based on that role. They're not escalated into that except if they have need for it because they're on call and there's an alert going on and they've gone through the workflow to get escalated in. Does that make sense?
It's more about the model of you have your everyday account and then an administrative account to prevent your phishing.
Yeah.
Yeah, they are.
Yes.
They are totally separate.
Yeah.
Yeah.
That was the point of the Taurus
Yeah. In
demo.
fact, in the demo that I showed, which I just shut down, I'm sorry. It said smart card, auth, and then it asked me for a particular account. That account was not my Microsoft account.
Okay, so that is an elevation account.
Absolutely. And by the way, that's an account that allows me privilege to go do things in that system, but it doesn't allow, to engage with the system, it does not allow me privilege to go do things in that system. So even then, for example, if I, in the absolute worst case, needed to hop onto a box, I needed to create a temporary password and username pair, a JIT account. So there's even a third layer above and beyond that I didn't show today.
So your admin account is really nothing more than like a only.
Well, if
Yes,
I'm going to,
that's right.
Yeah, if I'm going to
Unless
show you,
something extraordinary is happening, in which
That's
case
right.
another human being has been involved.
that's right.
Right, and it's not read-only, right. We don't want people to be able to read people's mail.
It's view only for the commandlets, but no data involved.
Right, just the overall system.
That's right.
Does that elevation process always go to a person?
No, not always. The elevation process, depending on what you're asking for. If we think it's destructive, if we think it is giving you access to key data, then yeah.
It goes to a person.
There has to be somebody at the top of that pyramid.
Yes. But we know the people. I mean, that's part of the trust system.
It's kind of like if it's one person, it could be militia. If it's two people, it's a conspiracy idea.
Yeah. And they're rare, so it's not like
Yeah.
you're constantly hitting approve.
Does that have an escalation? Like if you're asking, like say I wanted to go look at 1,000 tenancies mailboxes, would that go up several layers, or is that still just asking them?
It goes to a responsible individual. The way to think about it is, looking at one customer's data is as important to be scrutinized as looking at 1,000 customers' data. That's the way I would answer that question.
But there is definitely different containers and so on, so there would be multiple escalations involved for something that's truly broad scale.
So what about the, sorry.
Go ahead.
Okay.
Which one? One of you go ahead.
We'll point. I'll go point at you.
Is that process using like GIA and just enough and just in time admin?
Yes.
Were you guys doing that before that?
Well, those technologies I'm not sure about, but the words I totally understand, and that's what we're doing. Yeah.
And is there a move to look into what Jeffrey's bringing to us?
Yeah, we can have a more interesting conversation on this. There's some train of thought that says that the Windows subsystem is not inherently secure, and you could probably go back to Jeffrey and he'll find me and hunt me down. We're one of the ones that we believe that the Windows subsystem is not inherently secure. Yet. And we are working on fixing that problem, working with our counterparts in Windows. We actually worry much more about the Active Directory side than the local server side. That's one big difference between what Jeffrey's talking about and what we're doing. Because the Active Directory whole meal grants you godlike privileges. Even God doesn't know what privileges he has in Active Directory. And we don't like that model.
But our relationship with Jeffrey's awesome. He was the core guy behind PowerShell,
yeah.
and that was the start of being able to do this, was our bet on PowerShell.
Yep.
So my question is kind of in the same vein of the question before on the security side. What's the solution or the how we're going to solve the problem for like the mid-level defense contractor who has to meet the ITAR compliance and we can't come up with the 20,000 seat minimum requirement to get into the government cloud or the government Office 365 instance. Where's the solution there?
Okay, so you're feeling stuck because you're not quite big enough to qualify for our special stuff.
Right.
And so would you say mid-level, how big are we talking?
So 5,500, 6,000?
Yeah, okay. So that sounds like just a gap in our policies right now. Who to talk to?
We can probably
John Orton is probably the guy to send mail to.
We can probably take that offline too.
Yeah.
Okay.
But I would expect that we're going to scale down those, make sure those programs scale down too. I'm kind of surprised actually the threshold is.
Yeah, that seems a little
big for there to be actually a problem.
Yeah.
Okay. If you guys are enthusiastic about going to the cloud and you're only 5,000 seats, which is quite large, we should be able to get this fixed.
Okay. Appreciate it.
Behind you.
So you've done a significant amount already, tweaking and tuning and getting automation done. What is that next level that you're trying to aim for? 2, 3,
Right. Well, to some degree, one of the answers to that question is we kind of don't know. Right? We have a line of sight to a set of things that we're working on and working on, but one of the expectations is the system is going to teach us with new bruises what happens over the next 4x to 10x growth. And we have to be ready to be able to respond quickly, use the systems to predict which of the parts are getting ragged and move on. So that's one of the things that they're working on. Is there unannounced next steps?
There's some stuff we're working on which the system has already bruised us, but I don't think we're quite ready to go talk about it. But you can see where the world is going with the larger compute clouds and storage clouds. You know, containerization is a pretty interesting thing that's happening. Containerization of code, not containerization of physical.
But I would say, I think our biggest thrust right now that we don't think we really are where we want to be today is the number of geos in which we have multiple data centers so that we can be entirely within that geography from a compliance perspective. I think that is something that we're still working hard on with our peers in Azure to go after. And I think that is, getting more cost effective at that initial stamp size in those geos is the thing that we're really pushing hard on. And you had a question?
I was just curious. I noticed when you were saying you could go in and look and pull an audit for a particular tenant. Does that audit, can you get into things, not necessarily just an exchange, but can you also look into the underlying subsystems like Active Directory?
To the extent that we interact with those systems, yes, absolutely. Yeah. In fact, that's one of the big differences between on-premises, what I would call service management, and the cloud service management is in on-premises you can be very compartmentalized. You can buy one piece of software and then the integration job is kind of left to the IT staff or a third-party provider, just being honest. We can't dodge that bullet when we're running at this scale. So we end up getting our fingers into every single subsystem.
So in that sense you own your own Active Directory?
Yes. Yeah. We own the Active Directory devs who wrote Active Directory. So that we can do a better job at Active Directory. Yeah, good question.
Somebody over the other mic? No? All right.
All right.
Awesome. Thank you
you
very
so
much,
much,
everybody.